Hi, it's really great to be here. I haven't been in France in a couple of years, so this is pretty cool. I'm going to be talking about security in a containerized world. Kind of the focus of this talk, though, will be more the runtime security part, so like really hardening your containers. So if you don't know, I'm Jessie. I've contributed to a bunch of open source projects. A lot of the patches that I made to Docker and am now pulling back through to Kubernetes are for runtime security things, as well as just random other bugs that I find and fix. So a brief history of containers in Paris, because I feel like there's something really special about containers in Paris, in that the founder of Docker, came from France, and actually when I joined Docker, I think that Americans were kind of like a minority. So I learned things like, the best part of cheese is the rind, which is not something I was aware of before, and things about good wine and good champagne, which is very important. So really, Paris is kind of like the true home of containers. So it's really cool to be here. And I've also spoken at the Docker meetup here more than I've spoken probably at Docker meetups in the US, which is really weird. So the first time was in March in 2015, and then again in November of 2015. So I'm super excited for that tonight as well. But yeah, moving on. So what I'm going to talk about are security models, and then runtime security, and then network policies for your cluster. So the first part is really on how we are designing the security model for Kubernetes. So we have these various stages, and there's the kind of least secure one where the entire trust boundary is your cluster itself. So it's multiple user, but you treat the entire cluster itself as a boundary. So anyone who's running on it, you trust to be with the other users. And then there's cooperative soft multi-tenancy, which is what we get with the RBAC stuff in Kubernetes 1.6, and a bunch of features coming in 1.7. So this is good for multi-tenancy as one company, because you can get rid of bad actors and you can control what they can access. And then in the future, we're getting towards hard multi-tenancy that will have very strong resource isolation, and you can be comfortable running multiple people who you don't necessarily trust together on the same cluster, which is really good. So this is kind of what it looks like in the first model, where it's you trust the entire cluster as your boundary. All pods have the same permissions, all pods have full network access. Really, everyone kind of just has access to everything, which is not great, but as long as you are aware of that, you can spin up as many clusters as you need for as many trust groups that you have. So in the future, though, it would look like this, where if you're familiar with Kubernetes, the namespace will actually be the trust boundary, which is really cool. So as long as you separate your pods into different namespaces, and your teams into different namespaces that you don't trust together, then you will get this kind of thing. So kind of to go over each of these, you get authorization permissions at a more granular level. This came through RBAC, so users in the system will have least privilege, one person cannot see another person's things if they're not supposed to. And then the nodes will have their own individual identities, and each node will be least privilege. And then pods will have more fine-grained permissions, and your workloads can be granted permissions and not have all the system permissions by default. And then pods network access can be limited to whatever they need. So network, connectivity, you can use network policies to control that, and really define granularly what should be talking to what and what should not be. So yeah, that's kind of like the overall model, but as a focus on runtime security, I'll go over a few things like just with regard to Docker and with regard to Kubernetes, and they're pretty similar. So just to kind of cover something, I tend to think of containers and sandboxes as two different things. So to me, a sandbox is more isolated than a container is by default, just because you aren't allowed to do as much. So just to go over kind of my definition of a sandbox, like it will provide a net reduction in your attack surface, which containers don't do necessarily unless you actually tell them to. So if you compare like code execution from inside and outside a sandbox, you should be able to do less inside the sandbox than outside. And if you think about like if a hacker was to break out of your application, but they were still inside the container, you would want what they could do inside the container to be obviously less than what they could do inside your host entirely, which is kind of the whole point. So one of the most famous sandboxes is the Chrome sandbox, just because it's very good, like they designed it very well, and on Linux it's actually, interestingly, using the same primitives that are used in containers. So each tab actually in Chrome gets its own PID namespace, which if you think about it, it's to protect all this like arbitrary code that's happening, that's JavaScript, running from really knowing about all the other tabs and stealing tokens or anything from other tabs that you're running and logged in on, which is really cool. So if you're not familiar, a PID namespace is really just isolation at the process ID number. So the Chrome sandbox also uses other namespaces like unprivileged user namespaces and network namespaces. So the important thing to remember about unprivileged user namespaces is with that, you don't need cap sysadmin to actually, create or clone new namespaces. You can do it as your own user. So if you think about if you're running Chrome on Linux, you obviously don't like sudo Chrome. You run it as your user, so that's kind of like the key essential part there. And then it also uses setconf, which we also have in containers. So it's kind of neat that all the primitives are the same. So setconf is secure computing with filters. And it allows you to write these like programs that will basically allow or deny certain syscalls from being run. You could do a blacklist where you just like deny certain things, or you could do a whitelist where you literally list everything that you're going to allow. So BPF is kind of like the logic behind how setconf works and how it defines the filters. And it's used throughout the kernel in various places for tracing and a bunch of other stuff. It actually is like less buggy code than most of the kernel, so that's why everybody kind of builds on top of it. So that's good. So if we kind of take all those principles from the Chrome sandbox and apply them to containers, we would get like very hardened containers, which is kind of the goal here. So containers at their base are namespaces as well, and they use a lot more than Chrome, obviously. There's PID, mount, network, all these. Cgroup's a new one, which is cool. It doesn't exactly solve a problem that it should, but it is interesting. So the important things to remember about namespaces is that they control what a process can see, whereas cgroups control what a process can use. So you can control all sorts of things with devices, memory, CPU, pinned to a specific CPU with cgroups. Whereas namespaces are more like your host on the container, the network there is different than the network inside your container. So that's kind of cool. So that's the base of containers, and then on top of it, you get to optionally kind of run these Linux security modules, depending on which ones you have installed. And Docker turns them on by default if you do have them installed. So AppArmor being one of them, just controls like various process actions. You can write these profiles that are horrible and no one writes to define like what your application is actually supposed to do. So Docker has sane defaults with regards to like what you're allowed to read and proc and sys and preventing things like mount, which you would need cap sysadmin obviously anyways, but it's nice to have another layer there. So Kubernetes is getting towards the same thing. Today, if you want to do this, you can use an annotation. This is just for the time being so that we don't actually have to add a new type to the API. But you can run a default profile via this way, and then eventually that will be turned on by default as well once it gets into GA. So seccomp is another one of these as well, and you can kind of stack these one on top of the other so that you just have these layers of security, and sure, some of them kind of overlap, but it's nice if one kind of has problems. So seccomp we went over with regards to Chrome, but yeah, it allows or denies certain syscalls from being run. So Docker's default seccomp profile is a whitelist, and it just specifies the calls that are allowed. And it blocks a bunch of bad stuff, not limited to the following things. So the kernel keyring is not actually namespaced, as well as time is not namespaced, which means if you were to modify things in the keyring or you were to change the time inside a container, it would actually also change things on your host. And then other containers would then be impacted as well. So we prevent those things. And then we actually prevent cloning new user namespaces inside containers just because there are a lot of vulnerabilities found with user namespaces, so we might as well not nest them if you are running your Docker daemon with user namespaces enabled. So in Kubernetes, this is going to be turned on by default in 1.8, but what you can do today is kind of the same exact thing as AppArmor, and you would just put that you want to run with a default profile, or you can point to a local one on disk. So then there's SELinux. These are all super boring things. Provides a policies just like AppArmor. They're still not fun to write. And you can have individual labels over files and file descriptors and stuff like that. So in Docker, you can label volumes, and you can do. It also comes with a policy for the Docker daemon if you don't turn off SELinux, which everyone does. Kubernetes, you can also relabel volumes. It's just really important so that you can actually read the things inside your containers if you are running with SELinux, or modify things if you want to. One of the new ones that we're adding to Kubernetes that was already in Docker itself is no new privileges. So this kind of denies a child process from gaining more privileges than the parent that originally spawned it, obviously. And it applies to fork, clone, exec. So in Docker, it's not applied by default unless you turn it on in the Docker daemon setting, which I think is the thing. And then in Kubernetes, we're actually turning it on by default, but trying not to break set UID binaries, which is very hard because, yeah, problems. So there's a bunch of other settings in Kubernetes too with regard to security context. You can define that you want all your containers to only run as a non-root user, which is really nice and important. And then you can also define if you want a read-only root file system, which you can also do in Docker as well. And then you can define capabilities. So running as non-root, it's just a YAML flag. And then same with this one, read-only. And you can define which capabilities you want to drop. netraw, you probably don't need most of the time unless you're going to do something with ping. So that's all really interesting, but none of your developers obviously are going to do those things individually per each pod. So that's kind of why we have the pod security policies in Kubernetes, so you can define globally how these things will work throughout your cluster versus trusting your developers kind of to write their pod specs in a certain way that give them security. So your cluster admin can kind of define these rules that will apply to all the containers being run, which is really nice. So you can set things like privileged false, so no one can spin up privileged containers in your entire cluster, which is really cool. It might cause problems when people actually want to do that, though, because of course they do. And then you can also change which capabilities are added to containers by default, which is really cool. And you can require certain capabilities be dropped. That's supposed to say net raw. That is. And then you can also define which capabilities are allowed. So if someone wants to run a capability but you don't allow it, then they would be denied, which is really nice. You can also define which volumes should be allowed to be used. You can put an asterisk there if you want all of them, or you can, individually say the types of volumes that you're going to use in Kubernetes. You can also put down which ports should be allowed to be used. That way they aren't using privileged ports. And then if they should be able to use the host PID namespace or the host IPC namespace, which might cause problems with shared memory if you allow. So you can also set the SELinux options globally as well, for your entire organization here. And you can force that containers run with certain options. And you can also force that all containers must not be run as root here. And that way no one in your org will be able to do that, or will have to remember not to run containers as root, which is cool. You can define which groups you can add to containers so that not all are available by default. You can just say certain ones are and certain ones aren't. And then file system groups, same thing. And then you can define if all the containers should be run as read-only, which for an entire cluster might be very difficult, but yeah. So just a short thing on network policies as well. So kind of by default, the way it works today, all pods can talk to everything. So it's even if they don't need to talk to each other, you technically can, which is not great. So this is kind of what it looks like without a network policy. But if you actually define isolation with default deny, you could just basically drop all that, so you have nothing. And then you can explicitly define who should be able to talk to who through a whitelist. So, we can say these pods can talk. Just the X ones in a policy, you wouldn't actually put an X. It's just showing that if those did try to talk to each other, it would not work, obviously. And then the way to do this in Kubernetes today is when you are defining a namespace, you can put this annotation for default deny. And then you can define your network policies after that. So this policy is actually going to match pods with the role database. And then it's going to allow, connecting to port 6379. So just to give a small demo of something that I was working on. The 2 patches that are going into Kubernetes 1.8, which technically right now they're releasing 1.7, so it'll be in 2 months, are for the default seccomp profile in Kubernetes and for allow privilege escalation, which is our term for no new privileges. So if we look here, I have a cluster running. Actually, let me just. Cool. Make sure this is up. I'm gonna have to allow, sorry, 1 second, technical difficulties. Okay, there we go. Cool. Sorry, it was a proxy thing, but I didn't want you to see how I was doing the proxy. Okay, so I have these like running at a dirty commit, which sounds really scary, but it's just my branch that has like the new stuff with no new privileges. So if we just like show something real fast, really laggy TTY. So I have this like pod spec, and I'm just spinning up this container that I have called no new privs, but really it's just a set UID binary that's going to like echo out who the user is. So we can define our security context, and then we can tell this container to run as user leet, which is just, you could put anything there. If it was running as roots, like this wouldn't necessarily be as fun. So if I say, like, obviously that this should allow privilege escalation, then the set UID binary should work. So we can do like a kubectl. And then we can get our pods. So it's running as root. So the set UID binary worked because we allowed privilege escalation. So if we set this to false, which would be the default in this like new patched version, we can delete the old. And then create the new. And then we can get our pods again. That doesn't look great. Okay, well. Yeah, so this one's running as leet. I don't know why it did the crash loop back off, but whatever. Like basically your set UID's binaries would break, but in the case that you didn't want a set UID binary and something was actually trying to escalate its privileges, it would be denied like by default, which is really cool. So that's coming in 1.8 with seccomp support, and yeah, that was basically the update on Kubernetes things. I lost my browser. Oh, there we go. And yeah, that's how to control your runtime security.